with a little test to see if you've really learned something. So using your Inspire, find the exact solutions and vertex for each of the following. So you have two equations there. You are finding solutions to the equation. You're also finding the vertex if you were graphing that quadratic. Okay, but I don't have any information about what's going on, so you need to go down to Ivory and ask for her pass because I have nothing about that being something that you guys missed. Sorry. Give you one more minute. Get the answers that you need. Thank you. Thank you. Thank you. Okay, let's see what you got. So starting with our first one, 2x squared plus x minus 4 equals 0. You're being asked to do two things here. The first one is to solve it and give exact solutions. So put that in here. All right, so William, what did you get for your solutions for this? Oh, hang on a second. Turn my pen on. X is equal to what?
Parentheses of square root of 33 minus 1 over 4.
Like that?
Yeah.
Okay, do you agree with that? Is that what you got?
Yeah. And then...
Hang on a second. I want to make sure everybody's agreeing with that. Everybody okay with that? Okay. I'm going to ask somebody else for the vertex. For the vertex, Aaron, what'd you get?
Negative 0.303, negative, comma, negative 4.12.
Say that again. The first
Negative 0.303.
negative 0.03. 303. 303. 0.303?
Yeah.
Okay. And then your y coordinate?
Negative 4.12.
Agree with that? So I have to admit, I don't think I do. William, tell me how you did this one.
I just went to solving part and then typed in solve parentheses and then a comma x.
Okay? Is everybody clear with that? That you can go through your menu, go through algebra, choose the solve, just type in the equation as it says, and then comma, whatever variable you want to solve for. So in this case, we're just solving for the x, so comma x, and you get the answers. And if you're not getting exact solutions that look like this when you do that, it's probably because of the way your calculator is set. So you need to go to your settings and change it to exact answers rather than approximate answers in order to get those kinds of looking answers rather than decimal approximations. Okay? Aaron, tell us how you got your vertex.
I got the vertex.
Okay.
I got negative 0.25 and negative 4.0.
Let's try this again. So the x coordinate was what?
Negative 0.25.
Okay, and then y coordinate's what?
Negative
4.13. Okay, let's do that. Okay, that looks better. How did you get that?
You
Okay, so one way to do this is on your graph, type in f of x equals just the 2x squared plus x minus 4 part. Okay, and then do an analysis, go through your menu, analyze, and in this case find the minimum because that's the vertex, it's going to be the lowest point. Is there another way that you can come up with what the vertex would be? Harry?
I changed my equation to the vertex one using this word.
Okay, so that's another option based on what you saw in the activity. We have in the algebra, again, that completing the square command. And so if we complete the square, we're rewriting into vertex form. And so from vertex form, we can get the vertex that way as well. And so I think if you do it that way, you end up with a negative 33/8 for your y value, which ends up being a negative 4 1/8, which is actually 1.25. Okay, so if we want to get really exact, probably the completing the square is going to be a little better because when we do the analysis on our graph, our numbers tend to get rounded. Okay, so it depends on how exact you need to be. If you need to be really exact, completing the square is the better choice. If you're okay with something that's just close and rounded a little bit, then analyzing through your graph is okay. Okay, good. How about our 3x squared minus 2x plus 1 equal to 5x squared plus 10? Harry, what'd you get for that one for solving?
I didn't get it. I just said false.
So what does that mean? There's no solution. Yeah. So that happened, I think, in the activity itself as well. There were a couple, maybe 1 or 2 times where you put everything in and it's like, this is how I did it on everything else, and the answer you get is false. Well, what that tells you is that there is no value of x that's going to make that equation true. That's why you're getting this false response from your calculator. And so what that tells you in terms of our answer here is there's no solution. Okay, so graphically what's happening, if we were to put this into the graphing form, graphically what's happening is that we get a parabola that does not cross the x-axis. Okay, it's either going to be entirely above or entirely below. So if we don't cross the x-axis, we don't ever get answers or y values that are 0, and so therefore there's no x value that's going to make that happen. So anytime you use a command like this in your calculator and you get an answer of false, go back, just take a look at it, make sure that you've typed everything the way you're supposed to. And if you're confident that yes, I have it in the correct way, then what that false response is telling you is that there is no solution to this. You cannot find an x value that makes this true. Okay? Sorry? There could be. Yep. Yeah, we're just dealing with real solutions right now. So, yeah, it's possible that you might get imaginary solutions out of this. But within the real solutions. So sometimes you'll also see responses that say no real solutions or no real values or something like that, which means same kind of thing. Okay? How about a vertex? Jessica, what'd you get for a vertex?
Negative 0.5
Negative
0.5
0.5 and
negative 8.5.
negative 8.5. Everybody agree with that? Yep, I'll buy that. Okay, how did you get it?
I graphed it and I looked for the maximum value.
Okay, So one way, again, is graphically. This time, if we're subtracting the 5x squared over and the 10 over to get everything on one side, we end up with a negative a value. So it's going to be a parabola that opens down, which means that we need to be analyzing for the maximum value rather than the minimum value. Or again, the other way would be to do the completing the square, change it into vertex form, and then from the vertex form get those answers. So either way. Question? Sorry? How do you zoom out on the graph? Couple of ways you can do it. Let's see if I can get on here quick. Yeah, this is going to take a minute to come up. When you go to menu, you have a choice of window something. And when you click on that, you have lots of different options on how to zoom. One way is to actually just set the window settings to what you want. So I think it's the very first choice. It's like window settings. So you just go in and say, I want my x's to go from here to here. I want my y's to go from here to here. And then you see what you want to see. If you're not really sure what your x's and y's should be, I think there's a zoom out option. There is a fit option. So sometimes those two will zoom out enough that you can see everything you want to see. If it's a matter of just like a little bit, like you can see most of it, but not quite everything, I would say just go in and play with your window settings and adjust the numbers a little bit there, because you can probably guess about how much bigger it needs to be one way or the other. But if you just have no idea, then probably a zoom out or a so let's say it's this last one. What do we end up with? Negative 2x squared minus 2x minus 9 is what it would be, right? Negative 2x squared minus 2x minus 9. Whoops, how about 9? Okay, so I hit enter and boom! That was exciting. Nothing, right? I don't see anything. So here's a case where it's like, okay, I'm not really sure what my window needs to be because I'm not seeing anything. So that's when you go window or menu, and then window zoom, choice number 4. That's where you get all of these different options. Okay, so usually if it's just a matter of going out more, you can do a zoom out, and then your cursor becomes this magnifying glass that says center. And so if you think it's over here somewhere, where's our vertex? Negative 0.5 and a negative 8.5. So probably it's not. Probably it's more like over here. So wherever you click on the screen, that becomes the new center. So it'll zoom out, but it'll also zoom out based on that being more in the middle of your window now, until you can see something. And if I keep clicking on it, it will keep zooming out. Once I'm done, make sure that you hit escape to change your cursor back to a cursor and not that magnifying glass. Because as long as it's still the magnifying glass, every time you click on something, it keeps going out. It's like, no, go back. I didn't want to go that far. Okay. Any other questions from either of the calculator activities that you did? Anything that you couldn't make it work or weren't sure what the directions were telling you to do with it or anything like that?
We go over some it was like it's on page 1.2.
Of the file?
No, it's on
For the vertex.
No, it's question 13, and it's talking about like which form would be the best for like which one. And I answered them, but I want to make sure that I'm right.
On the vertex and factored form one.
Yeah.
Oh. Okay, so you have three different forms for a quadratic function. And the first thing you were supposed to show is that all three forms are equivalent. So how can you do that? How can you actually show that they all are actually equivalent? Yeah, so you multiply out the vertex form, multiply out the factored form, get them into standard form, and see if you get the same thing every time. Or if you really love factoring or completing the square, you can take standard form and try to change it into one of the others and just see if they all match up. But probably the most direct method is to take your vertex and factored forms, change them into your standard form, and see if you get the same thing every time. Okay? So we know that the different forms are all equivalent, they just look different. So then in part B, they're saying determine each of the following and explain how to choose the best form of the quadratic function for obtaining your answer. So if I want to know the smallest value of the function, what am I actually looking for on the graph? The vertex. So which form would be the most useful form? Vertex form. Okay, that's what they're trying to get you to think about. If I want to know what the x values of the zeros of the function are, that's going to be the factored form because they're going to give me those x-intercepts that we can call the zeros of the function. So the factored form would be most helpful. If what I want to know is the value of the function when x equals 0, well, what kind of point do I get on my graph when x equals 0? Y-intercept. Which one's the easiest one for finding y-intercepts? Standard. Okay, so that's what they're asking you to just kind of think through. And that process is actually really helpful because as we get into application kinds of problems that use quadratics, part of what form to set up your quadratic in will depend on what it is you're looking for. If they're asking you to look for something that is a highest height, how high will the object go, or a minimum or something like that, then that should click, okay, vertex. So if I can get this in vertex form, that would be really helpful. If they're asking you something about, we shot off this object and we want to know when it hits the ground again. Well, hitting the ground is like coming back down to our axis. So in that case, maybe it's factored form that's more helpful because I can get the intercepts. Okay? So thinking about what your problem is asking you for can help you to decide which form of your quadratic might be more helpful to make the work less difficult. Okay? Any other questions? All right. So let's start getting into today's lesson. On your tables, there should be a sheet that has 8 grids for graphing on each side. And this should be enough to get you through both what we're going to do in what we're going to do in class today and then what you need for homework. So this one sheet should be enough for you to be able to graph everything you need to today. I want you to take a shot at this without me telling you anything. Because you actually know enough to figure this out. Okay? You now know how to deal with quadratics in a graphing situation. You also have some knowledge of how to graph inequalities from our work with linears. I want you to take your knowledge from those two things and try to put them together to see if you can figure out how would you graph y is greater than x squared plus 3x minus 4. So I want you to try it first, and then we'll talk about what you did. Alright, let's try putting some pieces together. Looks like some of you are on the right track. Looks like some of you are a little stuck. So let's try to get unstuck and make sure everybody's on the same page. So let's just start by breaking this down with what we know. Okay, what do we know about graphing inequalities? So if this was just a linear, and I asked you to graph an inequality that was linear, what would be the first thing you would do? Julie?
Replace the inequality sign with the equal sign.
Okay, and what does that do? Why is that a good first step?
Because then we can see the borders.
You can see the what?
Borders. The border.
Oh, the border, okay. So the line, the border. Okay? So the first thing that we do is oftentimes replace the inequality with equals. To place the border, to know where the edge is between solutions and non-solutions. Okay? But then before we actually draw it, what do we have to decide? So if I've got my y-intercept and I've got my slope and I know where that line is supposed to go, what do I have to decide before I actually put pencil to paper? Henry?
Like the signs, like in like how to graph the signs and
Be more specific. What do you mean by that?
like when it's like y is greater than or like less than is always a dotted line, and then if it's greater than equal to or less than equal to, then it's a straight line.
Okay. So we have to decide whether we're going to draw it using a dotted line or a solid line based on what kind of inequality we actually have. Okay? So making that decision between dotted or solid. Okay? So now we've actually drawn the line, is dotted or solid depending on what we need, and then what's our third step? The shading, right? Because the line that we draw is simply the border that divides our graph into the side of the graph that has solutions at work and the side of the graph that does not have solutions at work. So once we get the border set, we still have to indicate which side has the solutions. That's where the shading comes in. how do we decide which side is going to get the shading? Always. When can't I use 0, 0?
When it goes through the origin.
Yeah, if my border actually goes through 0, 0, then I can't use 0, 0. So the idea is a test point, right? 0, 0 is one of the easiest test points to use as long as it's completely on one side of your boundary or the other side. If it's actually on your boundary, then you have to pick something else. Okay? All right. What do we know about graphing quadratics? What's the first thing we need to do for a quadratic? Anna?
You also replace the sign.
No. I'm not talking inequalities. I'm talking just a quadratic equation. Right? What we already know. We're not talking about doing this yet. We're just talking about what we already know about how to do things. So what's the first thing we have to do to graph a quadratic equation?
You first need to identify the vertex.
Okay, and how we do that depends on what kind of form our equation takes, and if it's vertex form or if it's standard form, all that stuff we talked about before break. Okay, so we know how to do that, but somehow we have to get our vertex. Once I get the vertex, then what do I need? How many? 5 total, so 4 more, right? That is still true. I still want to see 5 points total to establish where your parabola should go. Okay? So when we put these two together then, we're actually going to follow these steps, but our boundary now is going to be a parabola. Instead of being a line that divides up what works from what doesn't work, it's going to be a parabola that divides up what works from what doesn't work. Okay? So that means we actually have to start here by deciding where the parabola should go, and then kick it over here to actually graph it as an inequality. Make sense? All right, so where is our vertex on this one?
Negative 6. I'm sorry. It's negative 1.5 and
Negative 1.5, and then what was it? What?
negative 6.
Negative 6.25. Everybody agree with that? Is that what you got? Okay. Now, how many do I have here? 1, 2, 3, 4, 5, 6. I should have enough room there. So negative 1.5. And then negative 6.25 means I'm just a little bit right there. Okay, now what's another point that I can easily put on this graph? Y-intercept of? What is it? Negative 4, right? Okay, so negative 4. 1, 2, 3, 4. Goes right there. What's another point I can put on the graph as a result of that?
Reflected over the axis of symmetry.
Okay, so what would the ordered pair be for the reflected point?
Negative 4. Negative 4. Wait. Negative 3.
Negative 3, negative 4. It's over here. All right, I got 3. Give me something else to use. Henry?
I didn't factor for so the x-intercepts.
Okay, so what's factored form look like?
Parentheses x plus 4, parentheses
So that means my intercept should be where?
negative 4 and 1.
1, 2, 3, 4, and positive 1. Okay? So, now that I have the vertex and the 5 points, I'm kicking it over here, and I've actually just done the first step. I have established the placement of my boundary, of the parabola. Now, before I actually draw it, I have to decide, should I draw this as a dotted or a solid? Why dotted? Right. So that goes back now to our inequality and what inequality sign we're using. If it's strictly greater than or strictly less than, it's dotted line. If it's going to be greater than or equal to or less than or equal to, then that's when we use the solid line. So now when I go to draw this, let's see. I draw it as a dotted line. Okay? And then finally, I'm going to need to shade. But our shading now is not so much about one half or the other half. It's kind of more like, do I shade inside the U or outside the U? Because it's the U shape, that parabola, that is our boundary line now. So the question is, are my solutions on the inside or are they on the outside? Can I use 0, 0 in this case?
Yes.
Yeah. Doesn't appear to be on my boundary line at all. So if I put in 0 for x, what do we get? -4. And is that really less than 0? Yes. So that means then that the section that contains 0, 0, which is the inside of our parabola, is the section that should be shaded. That's our inequality. Questions on that? So theoretically, when you're asked to graph a quadratic inequality like this in 2 variables, there really isn't anything new here. What you're doing is taking 2 things you already know how to do and just bringing them together to do something a little different. But you're following the same steps that we used for graphing quadratics in terms of finding the vertex and then getting 4 other points. And then that really is the first step of the inequality, which is deciding where the parabola goes, where our boundary goes. Before you actually draw it, then you decide, am I going to draw this as a dotted or a solid, just like I did with linears. And then once I draw it, decide which side is going to get shaded, the inside or the outside, based on a test point. All stuff we know how to do. Any questions? Okay. So what do I do with that then? To speed this up just a little bit, I'm going to ask you to split this up. So, I want these 2 tables, 2 sets of tables, and you guys, I want you to come up with what the graph of the first inequality is going to look like. And then your set and these 2 sets, I want you guys to come up with what you think the graph of the second inequality is going to look like. Once you think you have it on your paper, share it with people around you to see if you agree. And then we're going to put both of them up here and see how we do this as a system. Okay? So just a couple of minutes, figure out just your one inequality, and then we'll put them both up here and figure out how to graph it as a system. have it, compare with the people around you and make sure you all agree on yours. First group, y is less than or equal to negative x squared plus 4. You guys feeling good about yours?
Yep.
You compared, you agreed, yes? Second group, y is greater than x squared minus 2x minus 3. You guys feeling good about yours? Yes? All right. Damien, you get to come up and represent your side.
Yeah, baby.
All right, so just a little smart board education here. With the pen, the top of the pen is kind of on a little spring. So you'll notice that when you write with it, it kind of moves a little bit. Okay? When you write, you have to get it to press just a little bit as you're writing. Otherwise, it's not going to write. Okay? Also, just a heads up, when you are trying to line up the point with the graph, it's just a little bit off, so just do the best you can. We'll get it. Okay? Go for it. Okay? Do you agree with what Damien did? There's one tiny little thing I'm going to be picky about now, so hopefully it doesn't lose you any points later. Any ideas? What's something picky that I might be like, this might lose you a point later? Sorry?
Axis of symmetry.
No, not so much. I'll let you start envisioning the axis of symmetry. 5 points. He gave us 3, which are 3 really good ones, the vertex and the x-intercepts, but we want to make sure we got 5. Okay, so 5 points on it. All right, so we're good with this one? Yep. All right, Chloe, you get to represent the other group. Let's change colors so you can tell them apart. Let's go with, what do you feel like? Purple, blue, purple? All right, there you go.
Yay.
Oh no.
Yep.
If possible, it does seem like sometimes if you put your hand on the board, it makes it weird. So try not to if you can. Okay. Okay, purple. There you go.
Thank you. Please stay at this.
It's okay. I do this all the time too, because when you're trying to do a little dot, it thinks you're trying to do something else. So. Oh. Oh. There you go.
Can I just do it with like a whiteboard marker?
No, because then it doesn't record. I'm trying to record it, so just kind of make it like,
Can I just have you draw it? Right there.
like that. Kind of make it like a big circle rather than
Okay.
trying to. Oh, more. Come on, you can do it. There you go.
Yay.
Oh, it's the ugliest graph on earth.
So what do you think? Just do you agree with that one? It's got 1, -4 as the vertex, opening up. So what you think? I honestly don't know. Yeah? You good with it? Yeah? Yeah. Okay, so when we graph each inequality individually, we get the green one or we get the purple one. But these are not just individual inequalities now. This is a system of inequalities. And so we have to think of this together. Which means that what I ultimately want to come up with for my answer are the values of x and y that make both inequalities true at the same time. So based on my graph, where do I have values of x and y that make both of my inequalities true at the same time? Exactly. The overlap is what you're looking for. Okay, where is the shading from both of my graphs in that section? And so what we end up with here, if I can get it in here, is this section right kind of in here. Let's see how far down we go, about right there. That is ultimately my final answer. Okay, because it's between those two boundaries that we have those x and y values that make both inequalities true. Okay, so again, very similar to what we already know about systems of linear inequalities. We look for that overlap. Well, the same thing happens here with parabolas, it's just that the sections are a little funkier looking. So what we end up ultimately shading is maybe a kind of a weird shape. The key to this, in terms of quizzes, tests, anything that's being graded, is make sure that whatever your final overlapped section is obvious. Okay, so if you're actually doing shading for both of your inequalities, make sure that the part that's overlapped is darker. The other thing you can do is just use some little arrows. Like maybe we start out and say, well, once I graph the 1, let's say I started with the green one, and I decide where I'm going to shade, I know I'm going to shade on the inside. So instead of actually shading it all, I just draw a little arrow that shows me I'm going to be on this side of the parabola. And then I do my purple one, and I realize, okay, I need to be on this side of that, and then I can imagine where's the part that those two would overlap, and that's only the part I shade. Okay? Another way you can be obvious about it is like what I did here. Use a highlighter on the test and highlight the part that's your final answer. But somehow you've got to make your final overlapped area obvious to me. If I have to guess at where I think your answers are, you're not going to be getting full credit. Yeah. Axis of symmetry is not so much necessary. I would still like to see vertex labeled. And obviously I'd like to see your scale labeled. So as long as your scale is labeled, you don't really have to label your intercepts and all of that kind of stuff. But vertices are still good to label. Okay? Yeah.
So if you don't like label your scale, is it just automatically assumed as like by ones?
Yes. And that is a personal preference thing. So every year you have to figure out what your teacher wants. But for me, if you don't label it, I assume that you're using ones. Okay, so if you're using a scale other than every box is 1 unit, then you have to make sure you're labeling it a 40 unit. Okay, any other questions on that? All right, let's take a quick break. Everybody stand up for a second. Been sitting for almost an hour. Okay, we're gonna see how skilled you are. I'm not even sure I can do this, but I saw this the other day, so I want to try it. Okay, put your fingers out in front of you. Okay, just with your right finger, just make an infinity sign. Everybody can handle that? Pretty easy, right? Okay, now, make the infinity sign with both of your fingers going opposite directions so that they meet in the middle, and see how fast you can do it without messing up. Okay, anybody feel like a director yet? La, 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 la. All right, now, stop. Now make them both go the same direction.
And still meet.
Okay, good. Now do this one. Take your nose with your left hand and your left ear with your right hand. Okay, and then you're going to go out and opposite. Okay, so see how fast you can do that without smacking yourself. It's not easy sometimes because your brain kind of wants to go, whoa. Feels kind of weird, doesn't it? All right, good. Sit down. All right, so our first two examples were examples of quadratic inequalities where two variables were involved. We had an x and we had a y. And either we were looking at a single inequality where we get a single parabola and we shade, or we had the system where we have to look for the overlap. But there are also inequalities that are just single variable inequalities. And so in these cases, in order to solve them, there's a little bit different technique to it. Okay? So, if you're looking at something like 2x squared plus 2x minus 4 being greater than or equal to 0, we don't have this y out here now anymore. We have it at 0. But let's just say for a second it was still y. Okay? If this was still y, then this would still have to be a 2-axis graph. Because I have two variables, I need two axes. Okay? What is my vertex for this one going to be? Anybody got the x coordinate? .5? Close, I think. I think it needs to be negative, right? Because it's negative b over 2a. So this is going to have to be negative 2 over 2 times 2
So negative 2 over 4 should be a negative 1/2. Okay, so now if I take negative 1/2 and square it, what's that going to be? 1/4 times 2, 1/2. And then if I take 2 times negative 1/2, negative 1, and then minus 4. So what do we end up with? Negative 5, negative 4.5? Yeah? Okay, while I plot that, see if you can factor this. See if we can come up with x-intercepts on that. I'll plot this. Anybody got factors? Yeah, I think.
2 times x minus 1 times x plus 2. That's wrong. It's negative 2. Okay, that's right.
So we good?
X minus 1, x.
So, good job noticing we've got a common factor of 2 and everything. So if we factor that out first, it makes life easier. So then we're just down to x squared plus x minus 2. So it should be a positive 2 and a negative 1 that'll give me the positive 1 for b. Okay? So that means my actual x-intercepts are what? And negative 2. So positive 1, negative 2. Okay? Now, since I'm not actually doing a 2-variable graph here, I don't really need to be perfect right now. So I'm just going to leave it with those. And I'm just going to say that as an equation, this would have looked something like this. Right? Okay, but here's the thing. This wasn't 2 variable. This was only 1 variable. So all I'm really interested in are the x's. All I'm really interested in are what x values are going to give me what I want. And what I want is that the answers to this quadratic, this 2x squared plus 2x minus 4, I need answers that are greater than or equal to that 0 that I started out with. Well, in a 2-coordinate graph, which coordinate represents the answers we get? The y's, right? X is usually what we put in, and y is usually the answer that we get. So, what I want to know is, when do I get an answer that actually is 0?
On the x-axis.
On the axis, right? At my x-intercepts. So at negative 2 and at positive 1, I get answers that actually are 0. When do I get answers that are above 0?
About x-axis.
Where?
Anything above the x-axis.
Anything above the x-axis. So this branch and this branch are representing answers that are greater than 0 because they are above the x-axis. When do I get answers that are less than 0? This part in between where it's below the x-axis. Okay? But what I'm asking for is what are the x values that make that happen? So the x values are all about which values are along this axis. So what are the x values that give us answers that are greater than or equal to 0? So numbers between -2 and 1 give me answers that are greater than or equal to 0. Yes? Is this the part that's greater than?
Nope.
No. So it's not the part in between in this case. It's the part out to the sides. It's these x values that are less than -2, and it's these x values that are bigger than 1 that end up giving me the parts of the graph that go above 0, that go up. So in terms of x values, what I want are these and these, because that's where the branches are.
Do you want to shade outside or?
Okay, you don't want to shade. That's the thing. On these, since they really are just one variable inequalities, we're not shading.
So it's just the branches.
It's just the branches. Okay, so here I think is a little cleaner way of coming up with the same answer. Based on this, based on what we've just seen here, here's how I suggest you go through this problem. Oh, let's go big. We got lots to erase here. So take all of this out of here. Get back down to what we started with, which was just an inequality in one variable that was quadratic. Okay? On this x-axis, what's important are the x-intercepts, because it was at those x-intercepts where our graph changed. On one side of our point, we were above the axis. As soon as I went to the other side of that x-intercept point, I was below. So those changing points are important. We need to know where the graph is going to change, and that happens at the x-intercepts. Those x-intercepts come from our factored form. So your first step in these kinds of problems is to factor. Because the factored form is what's going to give you where those x-intercepts should go. Okay? And so we factored. We've decided the x-intercepts are at 1 and -2. All you need to do on your number line is simply put a tick mark for each of those. You don't have to worry about scale. You don't have to worry about how nicely spread out they are. Just put 2 tick marks and then label them so that the smaller one is actually to the left. So that means I need the -2 to be this one and the positive 1 to be that one. Okay? And then instead of actually graphing the entire parabola to try to figure out what's going on, instead, we're going to take a bit of a page from the 2-variable inequality book, and we're going to use test values. So, what is an x value that would be in this part of the number line? Give me something. -3. Sounds good. I'm going to make this different color so we can keep track of it. So, let's make them green. So, a test value of -3 would come from that section. What's a test value that would be in between in this section of our number line? 0. Those are easy. Love those. What's a nice, easy number that would be in this section of my number line? 2. Okay? And using those test values, I'm going to test what kinds of answers I get in that section of the number line. Am I going to get positive answers, or am I going to get negative answers? Because my comparison here is with 0. I'm trying to figure out when is this quadratic bigger than 0 or equal to. But we've always got to make sure we're comparing to 0 so that we're just talking about am I positive or am I negative. So if you have something else on this side of the inequality, you got to move it all over first, just like we do with most quadratics. Okay? The nice thing is, because I've already done factored form, I don't need to go back to this to figure these answers out. I can go back to this. Because we just established in our calculator activity that all the different forms were equivalent, right? So if I go back to factored form, I'm still going to get the answers I need, but I don't actually care what the answer is. What I care about is it positive or negative? So when I take this -3 and I put it in for x here, is a -3 minus 1 going to give me a positive or a negative answer? Negative. Is a -3 plus 2 going to give me a positive or a negative answer? A negative. If I take a positive 2 times a negative, am I going to get a positive or negative answer overall? Positive. That's all I care about. I don't care what the actual answer is. I just care what's happening in that section. Is this section going to be the part that's above the line, or is this section going to be the part that's below the line? Do the same with 0. If I put 0 in for x here, negative. If I put 0 in for x there, it's now positive. So that positive times that positive gives me a negative. So this section is the part of the graph that's below the line. Then I use this test point. Put 2 in for x. Positive. 2 here. Positive. So positive times positive times positive. Positive. Okay? Now, what do we want? So we go back to our original inequality. We want answers that are greater than or equal to 0. So the first thing you ask yourself is, do I include my x-intercepts as part of my solution? Yes, because that was or equal to. So yes. Build in dots, include those points. Beautiful. And then, do I want the pluses or the minuses? The pluses, because I want answers that are bigger than 0. That means I want this section, and I want this section, because that's where the pluses came up. Plus, plus. So graphically now, we've just shown what our answer should be. Okay? Now when it comes to actually stating our final answer, there's a couple of ways of doing it. One is to actually graph it on the number line, which is what we just did. That's one way of showing what our solution should be. Another way is to write inequalities based on that number line. So if we go back here, whoops, to what we had, what would be the inequality that I would write based on what I'm seeing on this number line? It's -2. And which one? It's ors, because remember they look like ors. Have you ever heard that? The or graphs look like ors. Isn't that brilliant? Oh, that was really big. I need to go back small again. Okay, so this is going to have to be an or because we've got parts that are going opposite directions and they look like rowboat oars. So this is an or inequality. So what's the second half of my answer? Or x greater than or equal to what? 1. Make sure that when you do this that you're using the intercepts in your answer, not your test points. Okay? It gets easy to get a little bit messed up if you're not paying attention. So make sure it's your intercepts that you're using in your answer, not the test points that you had written there. So this would be the inequality way of showing what your answer was. I need x values that are less than -2, or I need less than or equal to, or I need x values that are greater than or equal to 1. Those are the x's that are going to make this inequality true. And then there's a third way, which is called interval notation. Okay? Interval notation is really going to communicate exactly the same way, just in a slightly different format. And the interval notation is something you're going to use more and more as you get up into higher and higher levels of math. So you'll see as you get into pre-calc and then you go into calc that these kinds of problems, more and more often, interval notation is going to be the way they communicate rather than inequalities. So it's not bad to kind of start getting an idea of what that is. In interval notation, we use parentheses and brackets. So rounded parentheses or square brackets. Rounded parentheses means that a value is not included, whereas square brackets means that a value is included. Okay? And within your parentheses or brackets, you always have these two numbers. The first number is the value at which your interval begins, and your second number is the value at which your interval ends. And so when you write it with a comma in between, you're saying that I'm talking about an interval that's between this and this, the first number and the second number. And then based on whether you use parentheses or brackets, you know whether to include or not include those endpoint values. Okay? So, in this case, it's a little bit strange because what would we say the starting number is? For this section, where does the interval start? That's where it ends. Where does it start? Negative infinity. Because there is no particular start point on this end. So in interval notation, we would say that we start at negative infinity, comma, and you always put parentheses with negative infinity because it is not a specific value.
Wait, it's not included?
So it's not included because it's not a particular value to include. Infinity is an idea. It's not something you can say, oh, there it is. It's right there on the number line. There's infinity. We're done. Right? So you cannot include infinity because it's not a specific value to include. All right, so from negative infinity up until negative 2, and are we including or not including? Including. So I need the square bracket beside the negative 2 to show that it's included. Okay, so this interval notation represents the same thing that this inequality does. Okay, which is what we're seeing in our number line right there. How about this piece? How do you suppose we're going to write x is greater than or equal to 1 in interval notation? Bracket to infinity. Yep, and then with parentheses. Because there's no end to how far we're going out in the positive direction. So it just goes to infinity. Sorry?
Why is infinity the y now?
Say that again?
Why is the infinity the y value?
It's not. These are not vertices. These are not ordered pairs.
Oh.
They look like them. So we have to make sure we understand the context that we're working in. This is not an x comma y ordered pair. This is an interval that says here's where I start and here's where I end. Okay? And that can be a little bit confusing, especially when we start using all parentheses yet too. It's like, well, it looks like an ordered pair. That's just a point. No, it's not. It's an interval. Okay? And then, instead of the or in between that we have to use when we're talking about inequalities to say that this is all part of the same answer, we use a set notation, which is a U which means union. So we're saying it's this piece along with this piece. We're putting the two together. So the U is union of those two pieces. And you need to have that in between, just like you have to write or if you're using inequalities.
What if it was and next to
If it's
Wait, we
and,
have
then you
one.
would just write whatever the actual overlap part was. So there really isn't an and that we need for interval notation. We just need the U. Okay? Any other questions on those? Yep.
For the not included part, would it just be parentheses next to comma 1 parentheses? Would it be just like that?
No. You would not want to list anything from the -2 to the 1 because when you write that notation, so you're saying if I wrote -2 to 1 like this with parentheses, you're saying that it's the -2 and the 1 themselves that are not included, but everything else in between is. And in the case of that particular inequality, those values did not work. So we don't want to include that interval at all. Okay? Good question. All right, so based on what we just did, I want you to try this one on your own. The one variable inequality. Use the graph to set it up first. Okay, so you should always have a number line as part of your answer. And then from that, I want you to write both what the inequality answer would be and what the interval notation answer would be. But set up the number line first to see how it's all going to work out. Okay, I know that wasn't a lot of time, but I just looked at the clock and realized that we're really short, so I want to make sure we get through this before we leave. So let's go ahead and walk through it quick. If you're not quite done, just pick up on the steps that you still need. So what's the first thing we have to do here?
Factors.
Yeah, subtract the 15, because we always want to compare our quadratic to 0. That way we can just look for the pluses and minuses. So subtract the 15 first, so that I'm comparing to 0, and then factor. Good. So what's this going to be in factored form?
X plus 3,
X minus which one?
5.
5. And x
Plus
plus 3. Okay? So from those factors then, what are my x-intercepts? 5 and -3. So those are what my two tick marks are going to have to be. Which one should I label that one? -3. Good. All right. So what would be a good test point in this section?
Oh, that's -4.
This section?
0.
This section? All right. So again, go back to factored form. It's easier. If I put -4 in here, is it positive or negative? Negative. If I put -4 in there, negative. But since I'm multiplying, if I take negative times negative, I get positive. So this section's positive. Okay? Put 0 in. That's still negative. Positive. So the overall is negative. Put 6 in. Positive. Positive. Overall. Positive. Okay? So now what do I want? Do I want to include My x-intercepts? No. So this time they're going to be open circles. Which sections do I want?
The -3 and
Yeah, so we want the section in between this time because we want less than 0. So we want the negative part. So as an inequality, what would that look like? -3. Good. Okay. As interval notation.
Parentheses, -3, comma, 5, parentheses.
Excellent. That's what you want. Okay. I'm not sure what your directions say in the book. The assignment's on Canvas. But even if it doesn't say it, I want you to practice writing your answers as both inequalities and interval. Okay? Practice both. See you on Friday.